Hello, everybody. I hope you can hear me well. Otherwise, please type something in the chat. I would like to welcome you all to the very first installation of our 2021-2022 speaker series on open knowledge networks. This is part of a program called the Convergence Accelerator by the US National Science Foundation, and more specifically, two tracks of this, track A and track B, where we are tasked to develop knowledge graphs for the broader public. And we are all very excited about this. In this speaker series, we plan to feature researchers and practitioners that are widely recognized for their contributions to knowledge graphs, knowledge engineering, fair data, and other similar topics. Our first speaker in this series today is Markus Kröetzsch. Markus is a full professor at the Faculty for Computer Science at the Technical University Dresden, where he's holding the chair for knowledge-based systems. He obtained his PhD from KIT, so Karlsruhe Institute for Technology, in 2010, and thereafter joined the Department for Computer Science at the University of Oxford until October 2013. He has contributed to the concepts and design of Wikidata, and is also very well known for his other contributions to knowledge modeling languages, inference methods, automatic reasoning, and so on and so forth. So before we are all here to hear from Markus, let me also announce already that our next speaker a week from now will be Danny Vredencic, who is going to talk about towards a multilingual Wikipedia. And Markus, I hope you're ready to go. We are very excited to hear about your thoughts. The stage is all yours, so let's start.
Yes, so thank you very much. Thank you very much for the introduction and for the kind invitation to speak here. I'm honored to see so many people turn out at this early or late hour, depending on where you are. Here it's late. And especially given that we are all in many video conferences these days, and I very much appreciate your taking time for another one. I hope I can make it worthwhile. Now, knowledge graphs for AI is going to be my topic, and I will be talking a lot about Wikidata, but before I do so, let me get started with some AI. So here you have it. This is AI as we all know it from the media. Nothing says AI quite like a robot with shiny plastic skin in bright white, which is, of course, saying much more about our society than about the actual technologies, and would be another interesting topic to discuss, but is not the topic of my talk today. Now, seeing this, of course, one gets the impression that there's a lot of hype and a lot of inflated expectations. But of course, this is not fully true. We know that AI is there. AI is really used, and we are using it in our normal daily lives, and in quite different forms. Yes, not as the shiny intellectual thinking robots, but rather as the serving machines like this one here. Actually, 2014 is the date I wrote here, so this is not even new. It's ancient in certain sense. Intelligent assistant Alexa, listening in on many people's bedrooms and living rooms these days, and serving all kinds of purposes. 2014, but maybe this was not really the start of AI in our public perception either. I mean, even 2 years before that, if you would go to Google, this is from today, this screenshot, but you could have that in 2012 already in similar fashion. You could actually ask Google a question. You could ask how many people are living in Dresden, and it would not return you just a simple page to read the answer for yourselves, but it would just give you the answer. And it does that now, and with some refinement, as you can see recently. Okay. So that's AI, right? But again, this is not really where it started. I mean, even 2010, we had intelligent agents in the form of Siri that many people have already used. And of course, agents like this are not the only case made for AI. It's not the only contact point that we have with AI. Some other developments happened in parallel. So we have this 2015, the year of smart cars. Yeah, so Tesla coming to the market, and there's a lot of discussions about AI and the possible effects of this, which very much shape our perception and of course also the research. I mean, as researchers, we are mostly focused on the actual technology and not on the hype only, but of course this all affects us in what we are looking at and how we are perceived as well. And as I said, 2015, year of smart cars, we have had other intelligent developments here, cars that are able to cheat on tests. Wow, very smart cars. Yes, so this is another type of software in our daily lives. I'm not even sure we should call it AI, but clearly a case of software which makes decisions, sometimes without us knowing, and which becomes and starts to become more important than the hardware that it's actually controlling. So another development and another place where we are seemingly losing control of things, which is also an important and recurring theme when you talk about AI these days. Okay, but AI is much more, you know, of course, especially in the media, AI is about playing games that humans were thought to be better at. AlphaGo 2016, but before that, Jeopardy 2011 with IBM Watson playing that. And well, even in the 90s here, you see Kasparov losing against Deep Blue, who is not the gentleman you see on the right, but is the IBM computer, of course. And again, this was thought as a breakthrough in AI at the time. Now, still, this is certainly not the start of AI doing things in a way that is perceived. I mean, you could go back to the 70s and talk about this thing here, four-color theorem, right? It's the first mathematical theorem, major mathematical theorem proved by a computer in ways that humans could not understand and still cannot really fully understand, but have accepted to be true. Yeah? So AI, yeah, in another way. And now, of course, with many of these example, following what is known as Tesla's law, that intelligence is whatever machines haven't done yet. Yeah? So we tend to dismiss things as soon as they work. And this has been refined recently, maybe also in the light of the public perception, by Fred Reed here, saying that when we know how a machine does something intelligent, it ceases to be regarded as intelligent, which is subtly different and has an interesting twist on this. Okay, so AI is many things, and it's difficult when I motivate the talk with AI to say what exactly this should encompass and what should it not encompass. But I hope I will have at least a clear direction in this talk. Okay, so how does all of that work? Obviously, I won't talk about all of this. So how does some of this work? How does, for example, Alexa work? So if you have Alexa and you say, Alexa, play Despacito, a popular internet meme years ago, probably nothing people remember these days, then it knows how to interpret this command. And how does it do that? How does it possibly find out what you want? Well, of course, as we all know, this requires machine learning. Yes, it requires some way to interpret your voice and to make sense of your query. But what it also requires, of course, and which people realize but may not have really as a mental presence when they think about these kind of assistants, is also a form of knowledge. It also requires machine knowing, because otherwise how would you know that Despacito is a song and that it's available in your music library and that playing is a certain activity? These things are not learned. They are provided by other sources in structured forms that computers can work with. Okay, so I'm going to talk about knowing, and knowledge in AI, of course, is widely important and used in many, many areas. There's specific knowledge and general knowledge that you need in all kinds of applications, and where only little thinking reveals that this is always there in certain ways. So question answering is the obvious main example. I have shown you some intelligent assistants, but of course, people in logical deduction, if you have knowledge representation and reasoning, there's a lot of knowledge. But also in machine learning, of course, there's a lot of knowledge used to correct machine learning models, to acquire the right training data and to supervise the outcomes. Data mining, language processing, there's always some amount of background knowledge. And these days, increasingly, this knowledge is represented using knowledge graphs. Maybe not just like this, but in a much bigger way. So knowledge graphs are a concept that has emerged in recent years and is fuzzy, I would say, at best. So it's certainly not a very clearly defined technology, but it is a concept, an idea that we represent knowledge not so much as a collection of records in a table, maybe as in the 90s relational databases, but more as a collection of things that are interconnected and where the actual information is in the relationships, is in the connections. Now, this has been used in very many forms, and I'm boldly saying here that knowledge graphs are the databases of AI. There has been a lot of perception of this, not just in the Gartner hype cycle for whatever it's worth, but also both in industry and in many big projects. So you see here some random news items from the web where people are talking about enterprise knowledge graphs, storing their knowledge on the enterprise level, a new form of data warehouse emerging with the flexibility of a graph and so on. Yeah? And many companies have been investing in this recently in order to build their own knowledge graphs, in order to serve AI applications, but also to do good old enterprise things that are important. Okay, now, I'm going to talk about one particular knowledge graph, the one which is already listed here in the corner, and this is Wikidata. Now, if we were all in a room, I would maybe do a quick poll. Who knows Wikidata? I let you do this in your mind and answer that question. Do you know Wikidata and what do you know of it? I think it catches on. I have started arguing for the need of Wikidata some 15 years, 16 years ago. And in these days, I still would start my talks asking around who knows Wikipedia. And it was not a majority in the audiences at the time. So things have changed and things are still changing here in the Wikidata cosmos. Now, Wikidata, of course, is the knowledge graph of Wikipedia. It has been around for quite a while, established in 2012, prepared for much, much longer. Yes, so we have been lobbying for quite a few years to get this started in the Wikimedia Foundation. But 2012 was the year when it first went online after some development. It is a free, collaboratively edited knowledge base, similar to what you have in Wikipedia, but not about text, as we will see in a second. And it is one such resource for all the languages. I will also explain that. Of course, not all languages, not even all which have a writing system, but many. Yeah. It is currently developed by Wikimedia Germany in Berlin, which is also where a lot of the design has happened at the time when we got this started back in 2012. And I should say, when I say we, of course, that Danny Frandicic, who is going to speak next week, has a major role in this. And I'm happy to be the first of the two speakers. So I can steal all his topics. But of course, he gets a lot of the credit of having managed this project for the first and crucial few years. Now, it is still developed by the team in Berlin, but there's also strong support from the Wikimedia Foundation in the US and hosted. It's in San Francisco and the other server places where Wikipedia is also hosted. Okay. Now, if you go to Wikidata, you see something like this. This is the page on Dresden. So there are pages where you have, similar to Wikipedia, one page per object. And on this page, instead of text, you find a lot of data. For example, you would find that the population of Dresden is a certain number. And you even have some second level information on this. So there's a point in time when this was actually the population and there was a method determining it. There's even a reference for this one. So this is the type of information you have here. And you can already see that this is much like a relatively simple data structure and typical, almost like a database interface, but not like a typical database. So this doesn't look like a table, for example. And the kind of information you could have here on the page is completely governed by the community. So the fact that there is a population for a city is not something that is built into the city design, but something that the community decides. And there are many other things on the same page. There's no fixed schema regarding what is on a city page and what isn't. And the same is true for the second level here, where you can also have all kinds of information. So describing this in terms of a fixed tabular schema as a traditional relational database would not make very much sense. Moreover, an important aspect here is that many of the data on the pages are linking back to other pages. for example, there is a page on statistical updating. There's also a page on, say, the Statistical Office of the Federal State of Saxony. I hope you can see my pointer, by the way. There's also pages for all of these properties here, like populations, point-in-time determination methods. So overall, this data really connects with other elements and therefore becomes something like a big graph, which is why we refer to it as a knowledge graph. Okay, now this data here on Dresden will look like this or similar to this if you go to the page, probably if your language is English at least. If you are using another language, you will see the same data in another language, for example, in Spanish. As you can see here, the information is the same, the number is the same, but all the labels have changed. The title is still German because this is a German publication where this number comes from. And this works for many languages like Korean or Arabic, where of course also the site layout will change to be right to left. Okay. And this kind of translation, of course, is possible. And when you have a data base like Wikidata is, because you do not have to really translate text, which is much harder and with something that Danny is going to talk about next week, I think. But you only have to translate the data points. So the population, for example, is a property and it has a label in many languages, including English. As soon as somebody defines a label in another language, every page using this property can be displayed in the appropriate language. So translating data is relatively easy compared to translating other things. And it has far-reaching effects. You translate one item and it will have impact on many places. Okay, now for this to work, of course, the identifiers, the things that we use to refer to the objects and to the properties here should not really themselves be labels in a language, but rather they should be language independent. And this is what they really are. So under the hood, and often not so much under the hood, but also in the daily work of people working with this knowledge base, you would use numerical identifiers to refer to all of these things that are connected here. Yeah, so for the objects, there's so-called QIDs, which are a Q followed by a number, and for the properties, there's a PID, because these are slightly different sorts, slightly different data types on the system. Okay, and so when you're working with Wikidata, you will see a lot of these numbers, which is a little off-turning at the first view, but something one quickly can get used to, especially since the labels are always not far away. So you can, in most applications, fetch the label very easily and then make a nice user interface or search by label very easily to have auto-completion and so on. Okay, right. So how did things go with Wikidata? Actually, it went amazingly well. When we started this in 2012, the site was empty. There was nothing in it. And it was a big critical moment for us to think this thing going online with everybody being able to edit it like Wikipedia and not knowing what would happen. So what would be entered, what kind of people would come along and what kind of data would they put into it. Would anybody care at all? Would it be a fringe community with maybe some very strange community governed rules that hinder other people? Or would it be possible to really make an open community that is productive and forward-looking and welcoming to people? And I think the latter has happened, and I'm very glad it did. So what we have today is a very big graph. As far as knowledge graphs I know are going, I would say more than 1.17 billion statements. A statement is something like what you just saw. Dresden has this population at this time point with this method and this reference. So all of this data, this whole record is called one statement. And of these, we have 1.17 billion, about 90 million objects. For comparison, English Wikipedia has about 6.3 million articles. Yeah, so you can see that this is way beyond the size of even the largest Wikipedias. Of course, also the things that are described in English Wikipedia are actually in there. In fact, if you go to any Wikipedia page and you see on the left of the page, usually if you're in English, the little bar which says this page in other languages, then these links that you find there also are served by the Wikidata knowledge graph. So all of this information, how the Wikipedia articles of different languages connect, is also stored in Wikidata. which is why everything which has a Wikipedia article somewhere should normally be represented in these objects here. Okay, in addition to the statements, there's also a lot of labels, as I have said, to do the translations. They are not counted as statements, so some 500 million labels, some 2.4 billion descriptions. These are the small texts below, which help you to disambiguate, for example, the Dresden that I showed you from other Dresdens in other places in the world. But of course, the main asset of this whole project is its huge community. So several 100,000 registered users have made active contributions to the knowledge base as it is now. And this, as I say, is the real asset, because the data is just free. Anybody can take it, and you're welcome to take it and put it on another website to call this your new Wikidata. But this will not last for very long, because the key thing is that you have people there who are maintaining this data. And this is a continuous challenge also for Wikidata, to make sure that the data that is contained in the system is actually maintained and maintainable. Because it's very easy to grow your database. It's very easy to pump data into a knowledge graph, but then it's difficult to make updates when the world changes and to have people who take ownership of the things that somebody has dumped there. So managing growth in a reasonable way, defining the boundaries of what is feasible and what is not feasible at current community size and engagement is very important for such a project to be successful. Okay, and I claim there are many applications. I can say a few things about this later on. Okay, now at this point, I assume you are convinced that Wikidata is very exciting and interesting and you should work with it. So I would like to tell you a few words about how you can access it. Obviously, you can visit the website, wikidata.org, which will give you pages like the one I showed you. This is, of course, for humans and not really for reuse in applications or in AI. It's not even really for humans, to be honest. If you look at these long data-filled pages, they are not a joy to read. They are not like a Wikipedia article, which is made for human consumption. They are just lists of things. But they are useful if you want to make changes and if you want to edit something. Of course, you can also download all the data, which is true for every Wikimedia project. There are regular dumps of all the information, even some of them with history version, where all the old versions are included. These dumps are large. So downloading them is not convenient, because you will need quite a while to download, first of all, but also to process the file afterwards to find something. So that's not a nice way to get in touch. So what other options do you have? There are APIs which are quite useful. So there's a very useful web API. All of the editing that happens on Wikidata is actually done through JavaScript-based APIs, or many of it is happening through JavaScript-based APIs. So much of the functionality that a normal user of the site would need is also available to any other program on the web. And this allows you to fetch data for individual objects. If you don't want to have the whole bunch, but just know what's in there about Dresden, you could easily get it immediately. And you can also perform, for example, string searches. If you want to find all the things that are called Dresden and have their descriptions, this is also provided by an API. And this is actually quite useful. For example, if you have the Wikipedia mobile phone app, this is using Wikidata in order to enable the search. Because when a user enters a string, you need to provide them a list of options to disambiguate what they might be searching for. So if you enter Dresden, you will get a list of Dresdens. And then which one did you mean? And hopefully the description from Wikidata will help you to decide whether it was the capital of Saxony or something completely different. And then you get the Wikipedia article once you have searched for the right thing, enabled by this cross-linking between Wikipedia and Wikidata. And there's also other ways. For example, you can use Java. There's Wikidata Toolkit. It's a project I started a few years ago and thankfully has been taken over by other maintainers now who have more time to properly develop this, and is also very capable of working with the data and can parse it and transform it to Java objects. Okay, these are other ways to access, but maybe the most exciting way to access Wikidata today is to just query the whole graph through an online service, which is at query.wikidata.org. So what can you do by a query service? Well, essentially, you can ask almost arbitrary database queries against the content of Wikidata. And it is then just up to your creative use of this to see what could be made of this. So for example, this is a simple query here that shows us how old US presidents are. So there's a list here with the age when they started their office and also an age when they ended it. And so this would be a basic simple query against the knowledge that you would find in Wikidata, for example. But many more things have been done and can be done. So there's always creative ideas. So here's another way of displaying a query result that is supported by this service. So where are people born who travel to space, and some color coding by gender, and there's a picture if you click on it. So these are interactive maps. You can do some data journalism with that if you want. Which 19th century paintings show the moon? Some nice ones of Dresden are here as well. This you can also query. So a lot of connections can be made by this, and a lot of things can be found that are very hard to find and to figure out today by web search. So these are really powerful, rich, expressive queries. Here's another one, number of tropical cyclones per year. I can see a certain trend here. I hope you can too. Right, so how does all of this work? There's a Wikidata query service, and I don't want to spend too much time talking about this. Essentially, the site is what you see on the left, and then there's the query service is what you see on the right. It's running a graph database called BlazeGraph, which is using the RDF data model to represent all the information in Wikidata, and the RDF query language Sparkle is then used to retrieve the answers to the questions you might have. If you don't know RDF and Sparkle, don't worry too much. These are popular graph database technologies that have been standardized by the World Wide Web Consortium some time ago. So this is basically semantic web technology now matured and used in industrial contexts for these large-scale applications. RDF is a very simple format, but one which is quite robust and well standardized. So it's a nice way to work with this. And basically, the actual content of Wikidata as a database is regularly translated and put into these graph databases. As I said, these are live query services, meaning that every change you make on Wikidata will be imported into these graph databases within seconds or maybe within a minute if there's no major outage at the moment. And outages are very rare, thankfully, for the query service, but sometimes we have a bit of a synchronization lag. Okay, so how does that work? I don't have time to give you details about Sparkle, but essentially what you can see here is the query in a online query editor, which also gives you a form-based view of what's going on here. As you can see, the query uses all these strange numerical identifiers that I have pointed out. And this group here on the form, you see a translation into English in this case for these identifiers. So what we are looking for here is are things that are part of the New York City subway, and we want to show the connecting lines, the coordinate location, and the image for each of these. So this is querying for subway stations, and if you plot this on a map, you get something like this directly from this query. So essentially, this is the code and this is the output. And you can click on any of these points to get the image that was retrieved. So this is an easy use of Sparkle, and it's not such a hard technology to learn, honestly, even if you have never seen it before. It's similar to SQL and other query languages, but you don't need to be a programmer to use it. And I think many people now in the Wikidata world have gotten used to it, even if they are not completely firm in other technologies. Also, there's a lot of assistance. There are help pages where people can request queries and others are helping them to formulate them if they have trouble figuring out how to put something in Spark. Okay, so what are the lessons learned from this? Actually, it was a big, amazing result for us. Even though we have already thought about this from the very start. I mean, I remember in 2006 also running around and giving talks about how you could query for the largest cities with a female mayor from Wikipedia. So this was our running example at the time. And so the idea that you could query this knowledge was always very important to us for as a motivation for making such a knowledge base in the first place. But still, I was amazed by how successful this was, given that it's still somewhat technically challenging to enter a query. So the query service today has some 100 million of answered queries per month. I don't have the exact number for this month. When we looked at it last time, that was in a study in 2018 when we had full access to all the logs. It was about this number, but I think it has grown quite a bit now. Also Wikidata has grown quite a bit since 2018. It's very good to see, and it wasn't clear from the beginning, I would say, when this was started as an idea to translate this into RDF and do it like this, that it would scale to the current size. So right now, the RDF graph version of Wikidata that is stored in these databases has 12 billion edges. There are live updates, as I said, every few seconds. Databases are synchronized, and it's open to everyone without a login. You can just go there and ask a query and have the servers run your query. So one could think this is quite a challenge to get this. And I think for many database vendors today, this would still be a challenge. So putting up their graph database or their whatever enterprise database on the web and letting everyone ask queries and see how this performs. But somehow with this semantic web stack of technologies, it went amazingly well. So I remember for many years, every paper in semantic web was complaining about how scalability is a big problem of these technologies. And, it's all nice and good to have these knowledge models, but they won't scale. But it turns out that people were so obsessed by it that somehow I think they didn't notice how people in the industry, like people at BlazeGraph, who developed this database backend, were actually solving these challenges over the years and creating very scalable, very nice systems. In fact, there was hardly any downtime ever of these services, not even at the start. There's detailed incident reports that you can see online on every case when there was some slowness, and detailed analysis of why it occurred and what happened and how it was addressed. There were 2 outages last year, actually. One lasted 10 minutes or 11, actually, to be precise, and the other one was about 2 hours even. But this was all that ever happened to this service. Okay, and I said lessons learned. I think the main lesson here is that humans in this case are more important than hardware. So the team in Wikimedia Foundation is quite amazing doing these things. So the servers, you would maybe imagine that these are large computers or compute centers, but this is not really true. The individual machines that are running Wikidata queries now are actually quite modest in size. So I think some $10,000 would be enough to purchase any of these machines. And there's a small number, like 3 to 6. It was 3 in 2018. I think by now there are a few more, but it's definitely not a whole server farm that is occupied by running these queries. But what is really important is to have very professional staff that is caring for these systems, that thinks about what is necessary to set this up in a nice and robust way. Okay, right. So did Wikidata do it then? So is it really achieving what we have dreamt of initially, namely that we have the sum of all human knowledge, a slogan that you will often see in the context of the Wikimedia Foundation? Of course, we could say Wikidata is the largest and most active free knowledge graph today. Also, I would say largest is not even important, right? As I said, anybody can take the data and merge it with their data, and then they have the largest, right? So size is not a big thing if you have free data flying around, but it is definitely most active in terms of what's happening. It's also one of the most active Wikimedia projects consistently since its inception. So in terms of edits, it's also been very successful. Nevertheless, we are, of course, far from having everything, right? So it's inherently incomplete. There are so many things in the world, and you just can't put all of them in. So as I said, we have about 90 million objects. If you look at other large knowledge graphs like OpenStreetMap, 430 million buildings, more than 15 million individual trees, which people find notable enough to be included in the database as a single tree. So this would be a sizable portion of our overall data set. So just as a comparison of how many things there are in the world. And of course, this is, you can never have it completely full of all the data that there is. And of course, there are larger knowledge bases, but they may not be as tightly connected. I mean, this is a web crawl. It's not really a coherent graph or a knowledge model. Also, knowledge modeling is very hard. So there's definitely a lot of challenges up ahead, and I'm not going through all of them in detail here. But creating this model is hard work, and it's the hard work of these editors that discuss this. It's not just a dump data entry job that they execute. It's much more advanced, much more sophisticated. Not last because of the internationalization issues, right? So if you have an international community, of course, they will have different conceptualizations of certain things without noticing, maybe sometimes even. And this has to be disentangled. One has to clarify how are we viewing the world together so that it works for all the languages. And there's a lot of discussions in this giant experiment, which I always find some joy in looking at. So this is taken from some of the discussion pages. So these are actually philosophical questions. So 1 or 2 items for one bridge in 2 locations. So somebody took a bridge and deconstructed it and put it into another place, the same stones. Is it the same bridge or should it be a new item? So this is Theseus' ship in another guise. Somebody is trying to sort out the different objects that represent York and whether they are the same or not, or whether it's conceptually different. Somebody says goal is a subclass of criterion, but isn't sure if this is correct or not. But it seems to be required by some of the database constraints that we have. And somebody is trying to model the fact that somebody died in a TV series and try to distinguish this from a dream that somebody else had where the same person died in another episode of that series. So these are small things, but all the small things that you have in such a model need such discussions. And this is not even touching the big questions like the edit war at Jesus Christ concerning the father property that we have seen at that time. Wikidata, of course, famously has, I think, 5 different items for Jesus Christ, because there are just different conceptualizations in different contexts that you cannot just throw together and say this is the one true data set. It would just not make sense. Okay. So is this really used? You might have doubts, and people have had doubts for some time. If you look at Google, for example, you see a number for the population of Dresden. And if you look at Wikidata, you see another number. It's not the same. So is anybody actually using it? And of course, with these big companies, you never know, right? So Amazon, Google, Apple, they don't show us their sources. They don't show us their processing pipelines in detail. We cannot say whether they are using Wikidata internally. Usually, unless something special happens, like in 2017, when somebody made this nice screenshot of their iPhone, where the question, what is the national anthem of Bulgaria, was answered with Despacito, which was surprising and was funny for people on the internet, but also a bit of a disaster for people working in Siri. So this is, of course, something you want to avoid when you have a company that serves knowledge and assistance. But this has revealed an important thing, because, of course, people were trying to track down why this happened. And the first go-to place was Wikipedia, and people were looking in history there, but this was never stated on the Wikipedia page of Bulgaria in any language. And so I think it was actually Danny who found out that there was a revision of Bulgaria on Wikidata, which actually gave this wrong information. It was there only for a very short time before it got reverted, but apparently Apple was unlucky enough to get a crawl or dump which was produced in these few minutes or hours, I don't know, when this wrong information was actually live.
Markus, okay. 5 more minutes.
Right. So let me speed up a bit. So there's many applications today. People have also become a bit more open. The companies have published papers about this. So we know also Alexa is using Wikidata as part of their resources. Google is using it for some things. There are also completely different applications, like here's a Eurowings flight monitor where you have cities on a map and where the about page is telling us that this is with Wikidata. Okay, so last 5 minutes. You may ask, what about machine learning? So let's come a bit back to AI. So it seems that machine learning does not actually occur in the most prominent AI applications today. You could think after my talk. And of course, that is wrong, right? There is machine learning in many places. There's you need to recognize spoken language or process written text or do image recognition with self-driving cars. So there's always a lot of machine learning, and it's very important in what it does. On the other hand, if you look through prominent AI applications, you see that all of them also have important and crucial machine knowing or knowledge representation components that you must not ignore or forget if you want to think about how AI systems work. So both sides are, of course, important. And you may ask now then, okay, why is it then that when we hear AI in the media, it's often considered synonymous almost with machine learning? Why is there such a focus on this particular technology? Of course, there will be many reasons, but an interesting one, of course, is that machine learning allows us to solve problems that we don't know how to solve. Problems that have been open for many years and where nobody had a good idea how to approach them, at least nothing that really worked, and now machine learning can do it. So they were the last piece of a puzzle with other pieces already there. Also, that's not quite true. You know, Wikidata is also recent and hasn't been there in the 70s. But of course, this is also, in a sense, a weakness of machine learning because it solves problems in ways that we don't understand. But observation in Tesla's theorem, of course, this is why we can still call it AI, even though it works, because not understanding how machines do it sometimes is actually a good thing. But this is, of course, a well-known issue that is discussed a lot and that leads people to the view today that explainability is essential for further development in AI, that we need to think about how to explain machine learning, for example. But I think just blaming machine learning on the lack of explainability is a bit too simplistic, and we shouldn't put all the blame on this one technology. I mean, there's this famous paper by Google researcher Scully et al. Who talked about machine learning-based systems and where the machine learning algorithm, this little black box, is actually positioned in the context of other aspects of the system that are important to have it run. And this is still a machine learning focused system. As I showed you, many other important AI systems have significant non-ML components. I mean, of course, it's nice if Alexa can explain to you why it understood your order in a certain way, why it thought that you were asking for the national anthem of Bulgaria. But this is not the point in this wrong answer. In order to understand why this answer is wrong, you have to have explanation also for the knowledge part of your component and for the process that has created it. And of course, even simple systems are very hard to understand, right? So the code used by Volkswagen to cheat in their cars is not a very long code. Also, it is quite hard to read. It doesn't seem to be made for easy understanding by the person who implemented it. But it is definitely not a complex AI system, and yet it eludes our understanding, and it is very critical as a component of the car. So let's not just blame machine learning. And at the end of my talk, I therefore just want to mention some approaches we are taking here in Dresden and with partners, for example, in our current interdisciplinary work with the Research Center on Perspicuous Computing. We are actually teaming up with people from formal methods and from user interaction and also from machine learning to create explanations and understanding for complex systems. And we think that this is truly not a matter of just one algorithm or one technology or one part of AI, but something where you have to have experts from several places in computer science involved and talking together to really create something like an understanding in the end. Of course, explaining machine learning will be very important and useful to have this, but it will not be enough. It will not explain the whole complicated AI systems that we are working with. Okay, another approach that we are taking has to do with the observations that actually some things are fiction, but still certain high technologies are actually reality when it comes to the processing of complex information in machine learning systems today and AI systems today. And this is in the high performance computing area. So this is a photo from of some of the computers that we have in Dresden next to our computer science building. And this is an approach we are considering in a large collaborative project called SCATS AI, which is a national competence center of the German government, where big data research and AI research is bundled. If you compare it to this Center for Research, which involves several universities and partners that I just talked about, CPAC, just think roughly 7 to 10 times CPAC per year. So that's roughly the size of SCUTS AI. So it's a big project, but of course it's also very broad. But what we are interested in there in particular is to consider also scalability issues, to also consider the big data part of this. And I have to admit, after many years thinking that myself, that the scalability is not the main problem for us, I'm coming back to the view that KR actually does need to think more about scalability. So for many years, it has actually been true that we were able to process the knowledge models that are out there very fast on very simple computers, on laptops in many cases. So the ontologies that were created in the life sciences, even the biggest anatomical models and the human disease models and so on, from the applications, we could all, classify in a few seconds. And we thought that this is it, right? But if you now look at Wikidata and other knowledge models of this scale, you suddenly realize that we need to think more about scalability again, because we are coming to the boundary of our current engineering approaches also when it comes to handling knowledge in this domain. So I think this is also something where we can definitely learn from machine learning, where a lot of breakthroughs have been achieved by scaling, by just taking things to larger data sets. And I think we have to go there as well in knowledge representation and reasoning. Okay, so this is it. Thanks for giving me a few more minutes. This is my conclusion. Knowledge-based AI is a key technology in modern AI platforms. Wikidata is huge, and I hope you are interested and will have a look of how you can make use of it. And explainability, I'm completely convinced, is not a matter of just looking at a single sub area of AI or a single algorithm, but needs to have a holistic view, which probably involves all of computer science, if not much more than that. So with this quote now of Hofstetter, AI is whatever hasn't been done yet, I want to conclude this talk, and I thank you very much for your attention. I'm looking forward to your questions.
That was a fabulous, fabulous talk. Thank you so much. I'm sure everybody's clapping their hands right now. They're just all on mute, so you can't hear them, but I'm sure everybody's super excited. Markus, that was really fabulous. And we have many, many, many people who already started typing in the chat. You may want to look them up, but it's a very long discussion. What I would suggest everybody does who would like to ask a question is to raise their hand using the raise your hand feature, so to speak, on Zoom. I already see Daniel Schwabe doing so. And Markus, please call them out so that you can pick the questions or the folks that you would like to hear from first. Is this good for you?
I don't see the hand. It's a list of attendees with the hands raised. So maybe if you can give me a pointer to get somebody
Absolutely.
started.
Daniel Schwabe, would you like to go first? You can unmute yourself and speak.
Sure, I'll go first. Thanks for the talk. It was quite interesting. I put the question, which I think is subsumed by other questions as well, which is the fact that in many statements, in order for you to accept it or use it as a true statement for some purpose, you require the knowledge of who is the author of the statement. So not just the reference used for that statement, but also who actually created that statement, which is obviously something that is available in Wikibase, but is not made available as data. So I'd be curious to understand. So this would not solve the problem, like other people are saying, when you have these wars and so on, which one do you accept as true? And my view here is that it's not up to Wikidata to really decide that, but just to enable others to apply their decision criteria to accept which ones they want to use. But it's necessary to have this provenance data available as data. Can you talk a bit more about that?
Yes, I mean, I agree. There's two kinds of provenance here, right? So the Wikidata itself does not see itself as a place where truth is collected, but as a place where we collect information from more trustworthy sources than ourselves. And there's always a reference where this statement came from. And this is widely used now. We have a lot of references, but of course you're right. There is another aspect to provenance, namely who created it. and by which process it maybe was created. Some of the, or many of the data that we have are actually created by programs that have certain versions, yeah, right, and that have been working according to some rules. And so understanding all of this is very useful to really track down why something happened. But I agree with you, it's difficult. So it's something that is in the data, so we can extract this. And some people have started researching on this. So in particular, if I think about the research done in Paris by Thomas Tanon, who has been who is also the maintainer of Wikidata Toolkit by now. He has created history databases where you can actually query for changes in Wikidata, and so you can have a better perspective on how the database has evolved, and not just about a fixed state of the database where it is now and what it says now. But yes, I agree.
It's not part of the data, right?
It is not part of
those
the data,
but are not represented as Q nodes and P nodes in Wikidata itself.
That's true, but they are represented as data inside the dumps. So you have this information is there. It's just not there as part of the RDF export at the moment. And indeed, there are some technical challenges of extracting this because Wikidata content pages are versioned as a whole and not statement by statement. So it's sometimes difficult to figure out who did what, but it can be done.
This is a fabulous discussion. Let me cut this short because there are so many people who want to ask questions. There was another Danielle asking a question. Now the hand disappeared. Danielle, would you like to go first? Or next, in fact? Okay, this person may have changed their mind or may have had to leave. Mustafa Jarrah, you're next.
Yeah, hello. Thank you very much for this very interesting talk, and thank you for the organizers also. My question is about the ontology of Wikidata and how it was built, how it's extended, about the process, and whether also there is some mappings with the WordNet, because we need the language level on top of the knowledge graph.
Yes, I mean, well, I think there are several questions here. So how the ontology was created is easy to answer. This is a community process. People are discussing it. And for a large part, there is no ontology. Yes, so the data model is discussed on a case-by-case basis. And there are constraints and expectations phrased in formal ways. Even checks is used if you know this technology. And some other forms of constraints are used. So there's quite a certain amount of formal information about the data structures, but there is no such thing as a global overarching ontology. So this is simply not there. And the other question about language, maybe I would defer to next week when Danny is here to talk about his project to make all of Wikipedia international. That's because there are many more aspects of language that I'm not an expert in.
Perfect. Thank you so much. I see Danielle's hand back up there. The second, Danielle, would you like to speak now?
Yes. Thank you. Sorry, my internet connection dropped for a second.
Oh, no worries.
So, thank you very much for your talk. My question was regarding the comment that you said that you are close to the maximum allowed engineering in terms of capabilities for querying. So I know that the idea for federation has been also being discussed in the Wikidata group. So my question is there going to be like a path forward for separating maybe different Wikidatas with knowledge that is of a particular domain or something like that? Because, for example, right now, I think 1/3 is scholarly articles that may be not very interesting for people with a certain application in mind.
Yes, I mean, so I would say the quick answer is no. Nobody is currently considering splitting off Wikidata or separating it into several disciplines, but the imbalance in terms of the scholarly articles aspects is of course noticed, and it might require some solution at a point. Yes, to some extent, what you suggest has happened with Wikimedia Commons, the big media repository of Wikipedia. There we have also now a lot of knowledge, a lot of structured data in the same way as in Wikidata. but it is on a separate site. So Wikimedia Commons would be an example of such a separate Wikidata instance for another topic area. But in many other places, especially when it comes to encyclopedic knowledge, as you would find in Wikipedia, it is impossible to draw the boundaries between the different areas, and therefore it's very hard to split. I mean, people have been composers, politicians, and scientists at the same time, and you can't just make a database for one of these. I think the case with publications is the extreme case. But even there are many publications that you would want to have in Wikidata as well.
Thank you so much. My list is constantly reordering, but I believe, Timmy, you're next. Tim Finan?
Hi. The type system of Wikidata is great, but of course it can be kind of overwhelming. And I always suspected that a lot of the types came from Freebase. Is that the case?
No, no, I think that's, I mean, the migration of Freebase data to Wikidata only happened after Wikidata had already gathered a lot of steam and had already a lot of data in itself. And it has always been imperfect. So not all of Freebase data has ever been migrated. So I think especially the structures and the data models used in Wikidata have not been influenced by Freebase very much. Also, I'm not sure which part of the type system of Wikidata you are referring to. I mean, Wikidata in spirit is very much like RDF. So you have, at the top level, you have properties, so the relationships between things, and they can be used in any context. Freebase was very different. It had at the top level a type system which considered certain classes of objects. So a composer could have certain properties and a scientist could have other properties. And Einstein would always have to be typed as a musician because he had an ID in some of the databases that are about musicians, because there are recordings of his speeches. So the type system, I think, in Freebase was much more complicated.
Well, I consider a type anything that has a subclass of property.
Oh, that's true, yes. But I think this has subclasses and subproperties are used in Wikidata, but they have very mild impact on the daily work of people. So they are mostly used to avoid redundancy and but people in practice are still being told, if you want to add this type of data, you have to use this property. The fact that it's then a subproperty of something more general, which will also be inferred, is only secondary and may not bother them at the moment.
Maybe I can get one more question in from the chat. And Markus, there are many in the chat if you have a time to peek at them. And one of them relates to the discussion we are having right now, namely, how do you perceive the future of the relation between Wikidata and DBpedia?
Yeah. I mean, so I can't speak for DBpedia, obviously. Also, Jens Lehmann now is also in Dresden and might still be working on this. And others, of course, have also contributed to this. Now, I think the biggest difference to understand upfront for everybody who is aware of these resources is that DBpedia is created by extracting information from Wikipedia texts. For example, English Wikipedia. And because of this, there are many different editions of Wikipedia, one for each language, and they are based on, for example, English Wikipedia. Now, as I have mentioned, English Wikipedia has 6.3 million things represented at all. So even if you have perfect extraction of this, you will only have 6.3 million objects, whereas Wikidata has 90 million things at the moment. Of course, some of them are publications, as we have just heard, so they could maybe be disregarded, but still, even without this, it's much larger. So by the very approach of how things are gathered, these systems are very different. DBpedia will focus on what is actually in the texts, and it can therefore maybe be useful if you want to make connections to the Wikipedia texts. I don't know, but if you are interested in only the data, I think Wikidata is the first place you would go to. Now, when it comes to the easy extractions, so the extractions where you can clearly from one Wikipedia get information, then I have observed that the Wikidata community has also done similar approaches. So in the time when Wikidata was still young and growing fast, on the things that are in Wikipedia itself, many people have created software that would extract some piece of information from some kind of Wikipedia page and then imports this in Wikidata. So you could say that maybe at some point, some of the content of Wikidata also was obtained in a fashion that is at least conceptually close to how DBpedia works. But of course, once it's imported, it still can be edited and it's still changed. And so it's difficult to compare the resources now. And already in terms of the schema, of course, due to the different types of extraction, you will have different properties, different kinds of data. So for example, in DBpedia, you have information about the color of a table on the Wikipedia page. This is something you will not find in Wikidata. But on the other hand, on Wikidata, you have information that you can get easily from databases, but which is just not found in any of the Wikipedia articles. So I would say if you're really interested in both resources, compare them yourselves and see for yourselves what you can make of them. But in terms of pure data, I would say Wikidata is more useful at the moment.
And that's such a great closing statement. I hate to cut you guys off. There's such a long discussion in the chat and many raised hands. We have exceeded our time here together. Let's give a big round of applause to Markus again. That was such a fabulous talk. And we are going to post it online as well with Markus' permission. If you have follow-up questions to Markus, then just reach him on social media or email or whatever is the preferred way to do.
Yes. I'm happy to answer questions if you can catch me in any channel.
Thank you so much, everybody. Please join us next week for Danny's talk.
It will be great. Yeah.